All right, good morning. So to start today, I would like to remind you about some items that are coming. Okay, just quickly. All right, your lab number 1, it has been released. You can think about officially it will start today. So if you didn't work on that yesterday, that's okay. So I would suggest try to work on that as much as you can today and also maybe tomorrow morning. So tomorrow in the scheduled lab session in the Williams Small Center, I will be there. TAs will be there as well, so you can definitely ask questions to make progress. Yeah, and the lab, I cannot emphasize more, it will be extremely crucial for you to actually do well in the later written test, programming test, and also exam for sure. I'll remind you about the dates, about the different assessment in just a moment. We'll look at the calendar together. And my office hour just as usual. You can just assume I will be there. All right, lab 1. And lab 0 part 2 will be very important for you to do lab 1. Because if you look at the lab 1, maybe I should really take a look together with you, highlight some important stuff. If you go to, you know what? Let me do that on Wednesday. I haven't really got my e-class set up on my laptop. But anyway, when you go to the lab 1, over there are 2 things you want to pay attention to. Number 1 is about the deadline for submission. That one is actually specified at the top of the instruction. Number 2 is about the programming requirements. To make it short, you are not allowed to use any Java library class in the solution. For the lab, if you decide to use it, that might be okay because we actually grade you just by submission. But in the programming test, you're going to receive penalty on using any Java library classes. So I would suggest, starting from lab number 1, you'll try to program your solution using primitive arrays only. That would be the way to go. I really want you to learn how to program everything from scratch. You'll find that you will learn more that way, rather than just relying on some methods that are already programmed for you, right? Okay, lab 0 part 2, it actually talks about how you can use primitive array. So try to really complete it as soon as you can. It will be due on Friday, but I would suggest try to complete it earlier so you can also make good progress on lab 1. And for your written test number 1, it's actually coming. Okay, let me just show to you, and then I'll also tell you what you can expect very briefly. Okay. And if you go under our course, the lecture site, if you go to semester calendar, you will see that we are now here, the 19th. So next Tuesday, 27th, during your scheduled lab session in the WSC, Williams Small Center, it's going to be in person. So I will give you more details after this Wednesday's class. Just about what you can expect. But you can assume it's actually going to cover lecture 1, 2, 3, 4, 5, right after Wednesday. I'll try to see if I can hold some review session for you guys, possibly over Zoom, just to see if you got any additional questions before the written test. But the written test is going to take in person in the WSC. It will be through the multiple choice platform in eClass. I'll give you guys some practice questions as well, maybe after Wednesday. So hopefully you will know what to expect. The big one is going to be the programming test one. For that one there, I'll definitely give you more information. I'm still kind of setting up the infrastructure. I might just be able to give you some mock-up test. So you will just be able to stay maybe after your written test 1 in the same spot. You can actually log into the computer and try the programming test there so you know exactly what the working environment is. I'll try to do that. I know that's going to be good for you. All right, that's basically what you're going to expect. And don't forget, lab 1 will be due on a Wednesday, not Friday. Only for lab 1. We want to make it due quicker so you can actually get ready for programming test 1. All right. Do you guys have any questions related to administrative stuff for this course before I start? You guys okay? All right. Yeah, if you got any question, always reach out to me. All right. All right, so I would like to continue with, first of all, this exercise over here. Presumably, you kind of try to maybe move ahead and try to complete tracing the program. But I'm going to do that to complete the solution in class, right? So you will definitely feel comfortable, hopefully, after today. I think this is where we ended up last Wednesday. And I kind of gave you some hints about how you can trace this particular loop. And the important question to ask yourself is, how many values is I going to take during the iteration? We know that it's going to take 0, 1, and 2. So there'll be 3 iterations in total. Specifically, for the very first iteration, we're going to replace I value over here just by 0. Right? That's what we said before. And let me write out the remaining 2 iterations as well, and then we can trace them. So that will be the first iteration. And then for the second iteration, it's going to be persons 2 at index 1 is assigned to persons 1 at index 1, right? And in the final third iteration, it's going to be persons 2 at index 2, and then persons 1 at index 2. Right? Just sum up very quickly. 0, 1, 2, 0, 1, 2, right? First, second, and third iterations. And depending on how I set up the loop header over here, the pattern might be slightly different on the index. But of course, you will need to judge, right? But once you know how to solve this one here, similar ones should be quite straightforward. All right? Let's take a look at how we can change the diagram. Oh, before I do that, after line number 6 over here, right? We are basically creating another array, persons 2, pointing to the beginning of the array. Initially, every slot over here is going to point to just null, default value, right? Let's make it explicit. Initially, it's going to simply point to null for every one of them. All right? And then, let's now try to simulate a loop manually. That's something you will have to know how to do in the written test. For the first iteration, this will be the variable assignment we want to do. We want to store this value over here into this variable. That's basically what we're doing. And what is this? This over here is basically the address that is stored at index 0 of persons 1 array, which would be over here, right? You can see that's persons 1 array. Index 0, that's exactly this one here. And of course, that one there is pointing to this Allen objects. That's the right-hand side. And the left-hand side is persons 2 at index 0. So that means we want to store at persons 2 index 0. That is, we want to store whatever that is over here into over here. But you don't want to draw the arrow like that. That's the wrong way to go. All right? Diagrammatically, we're going to say this part over here that's being changed is going to point to wherever this one is pointing to. That is, it is going to point to this particular objects. Right? Let me finish that part, and then I will see if you got any questions. So rather than pointing to over here, it's actually going to point to this one. Let me make it even more explicit for you. This part over here is pointing to these objects. Oh, beg your pardon. Let me do it again. This part over here is pointing to this object, right-hand side. This part here is what we want to change. So ultimately, it's also going to point to this object here. That's the very first iteration. Do you guys have any question? And the remaining 2 iterations will follow the same way. Yes? Mm-hmm. Yes, yes, yes. Yeah, so the question was maybe mainly about the variable assignments. Yes. So if you look at this part over here, right, this part here. If you look at this one over here is to say we want to go to persons 2 array and then go to index I. I can be 0, 1, or 2. We want to store the address in there. That's what we're doing, right? Of course, the challenging part is you want to be able to analyze what values I can take for each iteration, which I already explained. All right, good. Are we okay with the first iteration? And for the remaining 2, it will be solved in the same way. The second one, I'm going to do, let's just use green. Persons 2, 1 is assigned to persons 1, 1, right? That means persons 1, 1. So persons 1, index 1, is actually pointing to this particular object over here. We want to copy the address into persons 2, 1. Persons 2, 1 is over here, right? So now you can get an idea. So for this one here, rather than pointing to over here, it's actually going to point to wherever persons 1, 1 is pointing to. That one there is like that. Okay, let me just make it a little bit more. colored. So this one here, you can see is pointing to here. That one is corresponding to this. And assigned to here, so that one there is actually going to point to this. That's the second iteration. Okay, finally, what about the final iteration? So persons 1, 2. Persons 1, 2 is pointing to, this object over here, and then we want to copy that into persons 2, 2. Persons 2, 2 over here. So that means rather than pointing to over here, it's actually going to point to this object over here, right? And I will need to talk about a little bit of aliasing very quickly, right? Just make sure you're comfortable with the diagram. Of course, during the test, you may not be able to draw things in colored. So you may just want to do this diagram yourself as well, so you get used to how things are going, right? And you should be able to draw rather quickly. Since I'm trying to explain what I'm drawing, so you'll be a little bit slower. What I want to point out is about aliasing. Remember the definition for aliasing. You actually got the address of the same objects being copied into multiple variables. That's aliasing, right? Let me just give you one example. How many variables are storing the address of this object at the moment? How many? Give me a number. Let me repeat the question. How many variables are currently storing the address of these particular objects? 0, 1, 2, 3, 4, or whatever. Give me a number. 3, okay. I'm not sure if this is what you guys did. I think I can tell you the quickest way to tell is to see how many arrows are pointing to this particular objects. That's how you figure. So assuming that you actually draw the diagram quite accurately, you should be able to find the answer rather quickly. So we got one arrow here, pointing here, one arrow over here, and one arrow here. And for this one, I'm going to write it down. Let me just find out a place for myself. How about here? Oh, this may not be good. How about here? Aliasing. One example. Right, so this one over here is going to be Alan. And also, this one over here is persons 1 at index 0. At index 0. And the third one is over here. That is persons 2 at index 0. And something you can also check on Eclipse. Okay? Two things you can check. I'll just give you an example. You can say Alan equals persons 1. At index 0 at this point, right? So you can say something like, let me just write a little bit more over here. You can say Alan equals persons 1 at index 0. This one over here is going to return true. It's a Boolean expression that will evaluate the true, number 1. Number 2, what JUnit assertion can we write about it? There was a single assertion there that we said is going to check whether they point to the same objects. Do you remember what the assertion is? Assert equals, assert same. Yes, very good. You can also say assert the same, and then here you can put Alan, and I'm going to write in a little bit shorter. So persons 1 at index 0, right? So these are the two things you definitely should try yourself, all right? All right, so that's about what's going to happen after executing the for loop. And now we will be ready to go further to see how we can further manipulate the diagram. And there is something I would like to do, hopefully that will help the presentation a little bit. Since we got so many arrows already, so what I would do is this. Okay, so two diagrams, the same. What I would do is I'm going to be very explicit about the changes we have to make. Otherwise, you might just be confused about so many colors over here. So what I would do is, give me a moment, I'll set it up. Okay, that's where we will start. Okay, so we're going to start with here. This will be the first line we're going to start, all right? All right, let's start with line number 10. We say persons 1 at index 0 does set age 70. We're assuming that we got a mutated method which will change the age of the person. So what we'll do is, let's take a look. So you can see set age is a method which we assume is going to change the age attributes, either this, or this, or this, or this. But how do we know which one it would be? It depends on what the context object is, which is over here. So persons 1 at index 0 is pointing to this object over here. So we know that when we say persons 1 at index 0 does set age, it's going to modify the age over here to 70. That will be how line number 10 is going to modify the diagram. Are we okay with that? Of course, you have to know very well about what the context object is by looking at the diagram. So you can see tracing even program like this, it's not that sophisticated, only 18 lines. It's already not possible for you to think just in your head. I cannot do that either. I need to draw. Right? Okay. All right, let's go to the next line. And then we try to do system out the print line, Jim.getAge, Alan.getAge. Well, you can easily tell. Jim over here .getAge is going to give you 0. Alan.getAge is going to give you 70, right? That's the output. Okay. Let's now move on to the next one. Let me just do, how about pink over here? Oh, actually one more before I do further changes. What about persons 2 at index 0 .getAge? Persons 2 array is over here at index 0, and then that one there is actually pointing to Alan object, right? This object over here. And then the age should be 70. Are you okay with the third one? The third one might be slightly trickier, but you just trace the arrow. Are you guys okay so far? Just make sure, right? It's getting a little bit complicated, but hopefully not too bad. Let's say these two lines, let's do them together. What's this one going to do? It's going to copy the address that's stored in Jin into index 0 of persons 1 array. So that means Jim is currently pointing to this object over here. And we want to change persons 1 at index 0. That means rather than pointing to over here, it is going to point to this object over here, right? And then line 15, we want to set the age, but which object do we want to set? The context object is persons 1 at index 0. You can see persons 1 at index 0 has already been changed, right, to this object. So we are changing this one here to be 75. One thing I want you to remember, having this line here, well, without that line, will make the execution result for this line different, right? You can see after executing this line, we have already redirected the arrow of this one here to here. So that's why when we change the age, it's going to be changing these objects. Let's say if we didn't have this line, if we didn't have it, persons 1, 0 will still be this object over here. That means we'll modify that to be 75, right? So that means the context is really important, right? I guess okay? That'll be the last two changes we have to make. And then we'll just look at the diagram and figure out the answer for the rest. Good. All right. Yeah, sorry about the amplifier. It's a little bit annoying. Okay, let's now figure out the answer for the rest. Jim.getAge. So you can see Jim is over here, pointing to this object here. .getAge will be 75. Alan.getAge. Alan is still pointing to this object over here, so the age will be 70. Finally, persons 2 at index 0. Persons 2 at index 0 is actually still pointing to this object over here, right? And the age will still be 70. Of course, I'm just asking you a sum. But if I ask you more, you should be able to refer to the diagram and figure out the answer. Guys, one more question. One more question. Remember what I said before in the previous one? I said about the aliasing. For this particular object, we got 1, 2, and 3, right? Now that we actually executed more lines, at this point, how many objects are actually pointing to this particular, how many variables are storing the address of these objects for aliasing? How many? Is it still 3? 2, right? 1 here, 1 here. And this one is no longer there because it has been redirected. Okay, let me write it down. It's so important for you to observe that. Okay, so the aliasing over here, you can see we still got Alan, and we still got persons 2, 0, but this one here is no longer there. You want to see that explicitly, right, after the change. It's because we have executed these 2 lines. So if we look at the notes, just make sure you understand what I'm trying to do here. So aliasing situation is something that will change dynamically as you do variable assignments. Don't think that will just stay the same throughout the program. That's really the main thing for you to learn from this example. All right, so we have walked through this exercise very thoroughly, so I'm pretty sure you will now have a much better idea about what aliasing is, right? How we can redirect arrows and etc. Okay. Any questions before I move on? Please. Is there any way for me to possibly, if I put it here, would it help? Maybe. Yes, question, please. toString method. Okay, good question. The question was, what if you try to call the toString method? Okay. For now, let me just try to put it away. All right. Let's now try to actually try the toString method. Let's say, for example, if I can just make a little bit more space for us. Okay, let me just erase about the iteration here, so we got more space. Just enough. All right. Okay, about the toString method. If you simply try Alan dot toString, yes, at the moment it is actually going to print the address, whatever it is. However, in Java, there is a way for you actually to change, to say rather than printing out the address, you want to print out the contents of the objects. The way to do it is something like this. I'll just show it to you very quickly. So on your Eclipse, so I'll just take the class you actually had the other day, for example. Let me just go there. Let's say you want to do that for the person class. Let's say, oh, that's good. Okay. That's something we can try right away. Okay, let's say this. At the moment, you can see in the person class, we do not see the toString method anywhere. Agree? It's not there. By default, it's simply going to print out the address. Let's now confirm that. If you remember what I showed before, you can see Jim and Jonathan over here. I just printed out directly. The print line is going to implicitly call the toString method. So you don't really need to say Jim.toString, but I can say that just to be sure. This one will be a little bit redundant when you actually use the print line method. All right? Let's say Jim.toString. All right? If I try to execute this part over here, you will see that this is the address for Jim. Okay? But now, if I want to override or redefine this behavior, this is what I can do. I can say, just redeclare the toString method. Public string, toString over here. And now I want to say, rather than returning, printing out just the address, I want to print something else. Rather than returning the address, return something that's more meaningful. Meaningful in the sense that you can know more about the objects. For example, here we got the weights and the heights, right? So why don't we do that? We can say something like this. We can say string, the result would be weight, and then plus this dot weight, plus, I'll just say weight just for now, so you will see the idea. And then let's say return the result over here. Right? You can see the only difference I'm making is I'm adding this toString method. And if I go back to the tester, execute it again, you can see now, rather than printing out the address, it's printing out the weights. It's a complete answer to your question. So for the toString method, there are two cases. Number one, if you didn't redefine that explicitly in your class, it's going to print out the address by default. If you redefine that to whatever way you like, it's going to print out customized output like this. All right. But just for the purpose of my later illustration, I would suggest I just comment this out. But when I make the source code available to you, I'll make a comment over here. Let's say without redefining, or Java term is called overriding. By default, it returns the object's address, right? That's something you can play with as well. All right, any more questions about what we got so far? Everybody's okay? All right, so we're done with this exercise over here. Let's now move on. Let me see what's the next one. Okay, I want to complete this people project over here by defining one more method. And I want to put things together and just make some highlights, and then we can move on. All right, let's try that. We got so far in the person class, we got attributes, right? We got default constructor. We got the overridden constructor over here. We got the accessor, which returns something that's not void. And we want to now define the final category of method, which is called mutator. That means when you call the method, it's going to modify the attributes of the context objects. But let's see how. So I would say public void. Okay? It does not return anything. And then let's say gain. Let me just make sure I spelled it correctly according to my notes. Gained weight by this much. Okay? I will highlight some general principle of when should you actually supply parameters and when you shouldn't. I would say for this course, you are normally given the JUnit test cases, like in Lab 1. It precisely indicates the headers of your methods, so you don't need to worry about whether you should include parameters or not for the methods. But in case you want to define your own helper method privately, you may want to know the principle, right? I'll talk a little bit more about it later. In this case, if you want to gain the weights of the current person, I mean, the context objects, you want to know by how much the person should really gain the weights, right? In that case, we're actually going to, let me just go back here. Here instead. All right, so over here, we're going to include one input parameter, double weight. Okay, and if you don't want to choose the same name, you can choose amount if you like. It's up to you. Okay, we can say, well, the object is very easy. Just say this, the weight plus equal, right? You know what plus equal means, I'm pretty sure, right? Equals this dot weight plus amount. Okay, like that. All right. And of course, we have to somehow test whether this method actually works. The way to do that would be, we want to use JUnit test. Let's define another JUnit test just for our learning. I'll show you some new stuff in the test. So if we go back to the JUnit test over here, and for the test number 2 that we discussed earlier, I think back on last Wednesday, that's something I want you to type out to make sure you can do it. All right, so I'm not going to do test number 3. All right, let's do it together. That'll be the last one we're going to do in class. So I would say, number 1, you want to make sure you have the test tag over here. Otherwise, it will not be included for execution, for testing. And then, let me just take a look at what I should write. Good. Public, or if you want, just copy. That's fine. And of course, you want to make sure it has a unique name. Let's say number 3. Okay? Informally speaking, in this test, I want to create, again, Jim and Jonathan. And I want to get their BMI. And let's say both of them gain some weights by the equal amount. And then afterwards, I want to calculate their BMI once more to see how the BMI change. That's what I want to do. But how do we formulate it in the test? That's something I want to show you. Let's write it together. So we can say person Jim is new person here. And then we got 72, 1.81. Okay? Person Jonathan, new person here, 65, 1.67, right? Of course, you can feel free to actually write another test which will test different number, different measures for the weight and height. That's fine too. Let me finish the entire test and then we'll trace them. And now, this is something I want to definitely mention to you. About the assert equals, what I mentioned, I forgot either last Monday or Wednesday. For now, whenever I say assert equals, you can assume we want to compare numerical values only. But later, once we talk about the equals method in Java, things will get more complicated. But that's something to worry later. For now, whenever you see assert equals, it's going to be about numerical. And so what I'm going to say, assert equals over here. Can anybody remind us what would be the 3 things over here to put? Please.
The expected value, the actual value, and the tolerance.
Absolutely. Thank you so much. The expected value, the actual value, and the tolerance. And let's say here, I want to show you a trick, which I do quite normally, very frequently. Let's say, of course, if I got a calculator, I can definitely calculate what the expected value is, according to this. 72 divided by 1.81 squared. If I have a calculator, I can put a value over here. Let's say I don't. I want to somehow use the Eclipse to help me to actually get a value. I'm going to leave that just as 0, just for now, any value. Okay? And the actual value is going to be Jim.getBMI, right? Of course, assuming that the getBMI is actually correct. Okay? It's actually rather simple, so it's okay. And then tolerance, I would say 0.01 is usually good enough. All right? And apparently, this assertion here is going to fail because it's not possible for Jim with this measure to really have BMI 0. But I want to use the JUnit error report to help me out to see what the expected value should be over here. Right? That's something I want to show to you. What I want to do now is I want to go back to, let me close the tester just to avoid confusion. I'm going to right-click on the tests over here and then say run as JUnit test. Let's wait for that. Not surprisingly, it's a red bar, right? So currently we got test 1 and test 3. Test 3 was the one we just programmed. The font size is very small, but I encourage you to try it out on your Eclipse. But I'll show you what you should really try to find to read. If you go under the failure trace over here, there's a panel over here. Especially, I want you to look at the very top line. That's something you don't want to feel shy to look at. They give you lots of good information there. I'll read it to you. Okay? It says that the assertion has an error. Expected 0.0, which is what we put. However, it was returning 21.977. What this is saying is, at the moment, we are expecting 0, but this method here is returning that value I just read to you. So, assuming that the Jim.getBMI calculation is correct, we can put just the same value over here, just to make the test pass. Of course, if you want to be extra safe, you can just calculate that value in some calculator separately. But at least you can put the value here. 21.977. All right, if I do that, I'm going to have a green bar. Yes. Let me recap. Very important to know what I just showed to you. Whenever you got any failure, let me just reproduce once more. It is so important for you to see that. All right? Whenever you see any red bar, because you failed some test in your project, right? Let's say it is this test over here. You want to look at the top line to see what's really being expected and what's actually being returned by your method. That one will give you some very good hints about how you should improve your implementation. That's the number one lesson. For now, I'm just going to put it back. All right? And just to move things a little bit faster, I do know what the calculation is for Jonathan, so I'm going to put it right away. For Jonathan, the expected value should be 23.307. Not surprising, because we got different context objects, so that's why we got different values. All right? And then I'm just going to call the mutated method here, gym.gainWeights by, let's say, 3. Jonathan.gainWeights by, let's say, also 3. Even though they're gaining the same amount of weights, but since they're different objects, so the consequence might be different. So what I want to do now is just copy these two lines to compare their BMI. But of course, since the weights will be changed for both of them, we will expect the expected value here to also change, right? Let me just tell you what they are. 22.893. You can see this number here is larger than this number over here, which makes sense because he gets a little bit heavier. And then this one here is going to be 24.382. Right? If I rerun the test, green bar, right? Everything is passing. All right? Guys, are you okay with so far what I'm trying to show to you here? We got object creations here. We got accessor method call. We're calling the accessor method over here on different context objects. We also got mutated method call over here to change the object value. And also we got accessor method call to really compare the changes. That's what we're doing. And this will be something you'll definitely see over and over throughout the course. Right? I want to do a final thing to complete the example here. Let's do some quick tracing to see how things should be changed very quickly. All right? Okay, so that's the test number 3 I just illustrated, just typed. Right? Let's see very quickly. Number 1, we want to create the objects, Jim and also Jonathan. So let's say this one over here is Jim. This one over here is Jonathan. Okay, 72, 1.81. 72, 1.81. We talked about how the trace constructed already, so I'm not going to repeat the details. 65, 1.67. 65, 1.67. That's about object creation. And of course, when you do assert equals, when you say gym.getBMI, very quickly, when you say gym.getBMI, we know that we are calling the getBMI method over here, and the context object is gym. That means every occurrence of this will be replaced by gym. So we're using the same formula, but we say gym.weights, which will be 72, divided by the height square, which will be 1.81. That's how we get a value over here. On the other hand, if we try slightly different, let's say we do the second one, Jonathan.getBMI. The context object will be Jonathan. We're still calling the same method here, but this over here will be replaced by the context object, Jonathan. Over here. That one will be, you can see Jonathan.weights divided by Jonathan.height square, which will be this pair of numbers. So that's why the return value from here will be different. Right? That's something maybe you already know from the last week's review. Let's do something a little bit new. How about mutator? Let's say we want to change here gym.gainWeights by 3. So we're calling this method over here. Gym is going to replace this over here by 3. So gym.weights is over here increased by 3, 75. Right? And then let's do another one. Let's say Jonathan.gainWeightBy, right? So we're still calling the same method, and then we got Jonathan here. Replace this over here by Jonathan. So Jonathan.weights over here will be replaced by 68, increased by 3, right? So finally, if you try to execute Jim.getBMI, Jonathan.getBMI, you're going to use what? For example, Jim.getBMI is actually going to use these two numbers to calculate. If you try to say Jonathan.getBMI, it's going to use these two numbers instead. Of course, you'll get different expected values. That's kind of the tracing you want to feel very comfortable about when you see the OOP program. But that's something hopefully you will learn and catch up. Any question about this? Anything that's confusing or not as understanding as it should be for you? All right, I'll assume you're okay, if no question. I want to do a few more things, and then we'll move on to some new topics. Okay, this one here is a page I just made available to you last week, but let's just go over that very quickly. You already got a copy of this. This one kind of summarizes what we have reviewed so far, right? You got classes, you got objects, right? Classes are something you will try to compile in the editor. Objects will be something you create using the new keyword. And we got attributes, we got also methods in the classes. For the methods, we got constructor, accessor, mutator, and etc. Okay? This one here is something I can show to you maybe a little bit. Oh, I'll show you just one example. For those of you who may want to explore Eclipse further, you will notice that you can easily change things systematically. For example, let's say if I go back to the person over here, right? Let's say I want to change the name of this class over here to something else. For example, I can move my mouse over the person, right-click, and then you will see under refactor. Refactor is a special term we usually use in CS to say we want to change something systematically in your software definition. So we can say rename over here, and it will allow you to actually type some new name over here. Let's say, for example, I might say, let's say person1. Once you have done that, it's going to systematically rename every relevant place for this class name change, including the file name. Rather than person.java, it's going to be person1.java. You never want to change things manually when you could actually do it on Eclipse systematically. That's the main point, right? That's just one example. And you can change attribute name, you can change method name whenever you need to, all right? But just for consistency, let me just go back. Okay, I'll just rename it back. That's what I meant by refactor. Okay, I may have to. I think it's because I didn't save anyway. So you can play with it and just make sure before the last change, I should have saved the file first. I think that's why. Let me fix that very quickly. Let me see if there's any other instance of that I need to. Okay, let's say continue. Okay, always be careful whenever you want to do big changes, but play with it. Actually, it's quite robust in Eclipse about changing things. Okay, let me go back over here. Right, about the objects. We talk about every object has the instance specific values, as we have seen in many occasions, calling constructor and also using the dot notation to get attribute values and call the method, right? That's something we have seen so many times. And also the exercise we did. So that's a page to always remind you about what's the essence for OOP. Okay, should we take some quick attendance just to give you guys some credits? Okay, let's take it quickly. I know the question is so dumb as usual, but I will really try to get something for you at some point. Okay, but before that, let me just launch iClicker. Start a class. And then, let's say, do the poll. Make sure you do the poll. That's how I'm going to use to take your attendance. And select. All right? Yeah, choose any option. That's OK. Yeah, I'm going to wait for about 30 seconds or so. Just make sure you type in. You check in. 34, 35, 36. Yes. It's either you may want to fix that location service over there. You know what? I remember you. Mm-hmm. It's fine now? Awesome. Thank you. Yeah, make sure you take it, and then I will close it once you're done. Are you done? Awesome. 39, not bad. All right? Guys, thank you. So this will be the first official one, right? I'll do it sporadically. I don't necessarily do it on Monday. All right, I'm going to stop it. And then I'm going to close it. Awesome. All right. Let me now start with something else. Okay. So if you look at slide number 48, so this is something I want to talk about as well. This is also quite important to know. It's more about, not just about error. You know, of course, if you got errors in your class, you cannot execute the code, but it's more about style as well. Let's take a look at this one. Let's say we got our person class, and we got mutator, set weights, we got accessor, double. And let's not worry about top public. That's not relevant to the discussion here. We got mutator, we got accessor. The main thing is, for accessor, it does return something. So the principle goes like this. Whenever you are using an accessor over here, you're expecting some value to be returned. And that value that's returned should be used somehow. On the other hand, whenever you're calling a mutator, that means you don't expect any value to be returned. Rather, you expect the context object to be modified to some extent. Right? So that's a principle. And I want you to consider, let's say just this one here. We'll do mutator first. Okay, over here. We got 1, 2, and 3. I'll number them, just make it easier for you. We got 1 here, 2 here, and 3 over here. Right? What I want you to think about is, for 1, 2, and 3, if you type them in Eclipse, are they going to be okay? I mean, compilation-wise. Are they going to compile? Or any one of them is going to give you some error? That's the question. The principle should be, as long as you're using a set weight, like a mutator, which means you don't expect any value to be returned, that'll be okay. Yes, you want to say something? For you? Oh, yeah. You will all fail. Okay, okay, when you say you will all fail, you mean 1, 2, and 3, they will all fail? Okay, why don't we go over them one by one? I agree with you. Yeah, that's okay. Yeah, that's good. That's fine. Number 1, you will fail because gem.setWeight. Don't forget, that one does not return any value. It's like a void. You cannot simply print out something. You cannot use the value from void. You just cannot. Right? This one here is going to have some compilation error. You just cannot do it. The second one here is another way to use the return value, but which is not possible for a mutator. Gem.setWeights over here, again, is going to return void, which cannot be used in any way. So you cannot use it for assignments. That one is also not good. This one over here is actually fine. That's really the only way you should really use for mutator, which is to call the method alone. So this one is fine. All right? So it's about mutator. So 1, 2 will give you errors, but number 3 is not good. And just highlight one more thing, which is relevant to what we said before. For number 1 here, you can see we are kind of using gem.setWeight, this method call here. What we intend to do, let me put it formally. So here we intend to use the mutator call as the argument value. Right? We explained before what really what argument is. We're using the argument value over here, but we're using a mutator call. That's not good. You can only use accessor call, which will return something as the argument value, which we'll see. All right, so that's about mutator. Why don't we take a look at this one over here? All right. Let me number them. 4, 5, and 6. If you type them out on Eclipse, do you think you will get any error? I'm talking about error, like a red underline. Sorry, where? Yes. Give me the number. Which one will give you error? You think 4 will give you an error. Why? It does, okay, that's interesting. Let's look at 5 and 6 first. I can tell you 4 is a little bit confusing, slightly, but I'll illustrate to you. That's why I want to talk about it. Number 5 is actually okay. You're using the accessor method call as an argument value. That's okay, because it does have a return value. Similarly, you're using the accessor method call over here as the right-hand side for the assignment, which is also fine. You're using that value and store that into somewhere else. However, number 4 is kind of weird. You calculate a BMI for Jin, which is going to return something. However, you're not using that return value in any way. I would say that one there is not necessarily an error, but it's useless. So what if you try that in Eclipse? That one I want to show to you. If you go back to Eclipse, for example, let's say here. Let me just use the tester to show to you. If you go back to the console tester over there, okay, yeah, let me show to you here. And don't forget, in the person class, you can see we got getBMI. That does return double, right? If I go back there, let's say this. Jin.getBMI. Oops, no error. Even though conceptually, that's not the right thing to do. You're asking to do some computation and return some value, but you're not really using that value. You're just wasting the computing resources. But it's not considered as an error in Eclipse, okay? Useless, wasting computing resources, but not considered as an error. So that would be the special case I want you to know. And the reason I want to point this out, I have seen so many programmers defining some accessor method, but they actually only use like this. That's not a way to go. Right? You're not really getting anything useful from the return value. All right? All right. And that's kind of the general principle I promise. I can go over very quickly with you what I wrote here, but I would say as to the design for the methods for this course, for the public methods, you will always be given the headers for the public methods in the lab or in the programming test, so you don't need to worry about the design. However, I would say these principles over here will be useful for designing your private helper methods, which you might find useful going to lab. Right? That's something I can maybe give you more maybe personal guidance when I see you in person, maybe in the lab or office hour. But I'll just give you principle here. Mainly for private, yeah, sorry about my writing here. Private helper methods. Because public ones are usually just suggested to you by JUnit test cases anyway. All right? All right, let's talk about it. Constructor, basically, you're going to think about constructor usually are meant for initializing the attribute values. Think about if you really want to get some specific input values for initializing the attributes. If you want, then you should really get parameters for the constructor. That's the principle number 1. Principle number 2 is about mutator. A similar principle. Think about what the intent is for each mutator. You're supposed to actually modify some attribute value. For example, if you go back to that example here. Here. This one here, gainWeightBy. This method here is only meant to change the weights. So that's why we got exactly just one parameter here, meant to be changing the weights. We didn't have 2 because we don't need to change the heights. There might be just another mutated method. I may want to say gain, weights, and height. In that way, we might want to take 2 parameters instead. Right? So depending on how many attribute values you want to change in the mutator, and then you would design accordingly. One more principle about accessor method. Accessor method usually just for you to get some information about the current objects, get BMI, get a weight, get a height. So think about in order for me to get a result, do I need any extra input in addition to the attribute values? If I do, I need some extra parameters. For example, let's say in the point class, if I want to know, let's say this, if I got P1, and then I want to get the distance from the origin. In this case, because I already know the coordinates for P1, x and y, I know origin is 0, 0, always. So I don't need to pass 0, 0 over here. So that's why it was just no extra input will be needed. On the other hand, if I want to know what the distance is from the context object to another point, I need to know what another point is. So that will be P1 dot get distance from maybe P2. You can see the difference here. So here, no arguments being passed. Here, one single argument, depending on what extra information you might need for the accessor. So these are just the general principles, but it really is up to your experience with programming more. Right? We can talk about it more if you got more specific questions for me. Right? Are we okay with this general principle? All right. But you might just get more questions as you dive deeper into level 1. Okay, so I want to go to slide 53. I do have a good small number of topics I want to cover today. If I cannot, I will spend maybe just about the first 15 to 20 minutes on Wednesday to finish them. And then we're going to move on to exceptions. All right, let me now go to the slides 53. Okay, let me just go there, and then we'll talk about the stuff. We've got some interesting exercise to do together as well. Right, about data types. Oh, you know what? Before that, I want to highlight one more slide for you. Let me just check the slide number. Give me a moment. Slide 14. Right. So this slide here is very important. It talks about primitive type versus reference type. And we talked about primitive variable versus reference variable last time on Wednesday, right? That's something I want to make sure you review to understand. Primitive value simply store some maybe numerical value, character value, or Boolean value, simple value. For reference type, you store the address of some objects, not the object itself. Right? So these are the two important distinctions for you to make. And of course, the next slide is about the default value for each data type. For reference type, it's very straightforward, always just null if you don't have the address just yet, like an invalid address. That's the first thing I want to point out, and then I want to go back to that particular slide, which is 53. Let's see how we can make use of the data type idea in Java class. Let's say we want to declare attributes, right? Basically, you want to think about in this scenario like this. Let's look at the example a little bit later. For now, don't look at them just yet, okay? Let's say I'm trying to declare some class over here. Let's say class, my class. And then over here, I'm declaring some type of my attributes. Let's say ATT, right? This part over here will be the type of the attributes. Can be primitive, which is straightforward. And also, it could be reference type. Even for reference type, we can subdivide into two possibilities. Either it can be single valued, or it could be multi-valued. And for multi-value for this course, mostly it will be just array. Okay? And let me just give you one example right away. Let's say if we have a person class, let's say a person, right? Let's not worry about the public and private. What would be an example of a single valued? It could be, let's say we have another person over here, which would be maybe your spouse, which may be void, which may be null if you're single, right? Spouse. This will be single valued. Another one could be maybe children. Person, array. Right? You can see this will be an example for single valued, and this will be for multi-value over here. Right? That's something you will definitely see in Lab 1, and also Lab 0 Part 2. Right? And what I want, let me go over some slides, and then we'll do that example together. Also, for the parameter of your method, it may also be a reference type, meaning that when you actually call the method by passing the argument value, you simply pass some reference variable. We'll see it on the example. And there's something called callback value, which will make the scenario a little bit more precise. And that's something we'll do a little bit later, possibly closer to the reading week. What I want to do now is to do this example for you, together with you, about return value. Let's say the return value of some method, so we are defining some accessor. The return value itself is in objects. But how do we understand it? Let's take a look. Okay, so now we can now look at this example over here, right? Let me just set up the context for you. Let's say we still got our point class over here. We got one mutated method move up, which will take one parameter. We want to know how much the point should move up by adding to y, right? Of course, here, since I does not clash with the x and y attributes, so there's no variable shadowing issue, so we can just say I. So we don't need to say this dot y, just for your information. And also, we got another accessor over here because it returns something that's not void. So that one there is simply returning point. And we want to move up by I, but this one here is going to return an object back rather than modifying the context objects. So this will be a nice example for you to distinguish between the two. One method here, let me write it down. This method here does not return anything. It was only modify this. On the other hand, this method here is not going to modify the attribute of this. Does not modify this. Instead, it would modify some local variable. Right, just remember. Oh, but we're going to dive into complete details to see how to trace them. All right, let's now take a look. So this will be the tester I want to use to trace the program, so we can see how they work. Okay, let me just highlight them very quickly. So that's the mutator, and this one is the accessor. All right, let's try to trace the program line by line. Let's create P1. So P1 is actually going to be an object, well, stores the address of the objects over here. We're assuming that for the point class, we got x and y. So 2.5 minus 3.6. 2.5, and then, let me just draw it better. X and y, so it would be 2.5 minus 3.6. All right, so far so good. All right. And I would like to modify the value for P1. You can see P1 is being used as a context object. I'm calling move up. I'm calling this mutator over here. And then you can think about there is some implicit this dot y and also this dot y. Every this will be replaced by P1. Right? So P1 dot y will be is assigned to P1 dot y plus 7.8. Right? So it's going to modify just this one here plus 7.8. Right? 7.8, it would be 4.2, I believe. That's how you do it. Are we okay so far about the first two lines? The first line, we create P1, call some mutated method to change its attribute value. That's what we're doing. Okay? And the next two lines will be the tricky part that we need to understand. Make sure you're okay up to now, right? Up to now, nothing's new. All right, let's now try to do this. What we want to do now is to call P1.moveUpBy. Okay, let me just draw very quickly about what we have got so far. Initially, we got P1. It's about here, 2.5. This is the initial P1. 2.5 minus 3.6. And then by calling this mutator over here, we are moving that P1. Rather than here, is going to be 2.5, 4.2. How about here? Right, that's a new P1. That's what we have done so far, right? Still the same P1. And if we try to execute the next line, let's say P2, this line here. P1.moveUpBy, right? The intention is we do not want to modify P1 itself. We just want to use its information and then return another object. That is why you see point as a return type over here. How do we create that return value point? Let's see. What we want to do is we're going to trace line by line how this method is going to be executed. You can see 6.4 over here. 6.4 and 6.4. All right? And then let's see. Locally, inside this method, we're going to have another point, MP, new point. So what's going to happen is we're going to have MP pointing to a new point object. And then, how do we create this new MP? You can see it will be a new point, X and Y. What are the X and Y over here? Can anybody tell me? Somewhere. Did you say something? Oh, you, sorry. X, Y of P1, yes. Yeah, actually, in this diagram here, you have no choice, right? You got to choose those values. But I don't want to choose them just by coincidence, right? Let me be more precise over here. So here, you want to understand this way. Implicitly, X over here is this dot X. Y here is this dot Y, right? What's this? When we call this method here, the context object is P1. So that means every occurrence of this will be replaced by P1. Be careful, as I said, now it's simple because you only got this choice. But it may be that I set out other points in the context, so you might just get confused, right? You want to know how exactly to infer this. When you call this method here, the context object is P1. So that's why you're going to replace every occurrence of this just by P1. So that means you're going to get P1.x, P1.y. P1.x, P1.y, right? So it would be 2.5 and also 4.2. It's a local point. It's a local variable. And if we go further over here, right, we're calling the mutator method here move up, right? And here's a question. By calling this mutator method over here, we got 2 point objects. Are we modifying this value here, or are we modifying this value over here? 1 or 2? 2, okay. For those of you who thought it would be 2, that's correct. Why? You can see here, the context object here is MP, right? That's why. Be very clear about how things go to move together. MP here, context object, right? So if you call the move up, it's going to modify the MP over here. Well, of course, you can trace how to call that method, but I'll let you do that. So by 6.4. So that will be 10.6, I believe. Right? That's the modification. And finally, you're going to return MP over here. Return MP means you're going to return this particular reference back to, as a return value. So that means this part over here is going to have the return value MP, right? Let me just draw that quickly. So think about this one over here will return MP. Right? That's the final one, MP. And MP here will be stored into P2. P2 is just another variable. So P2 is going to point to wherever MP is pointing to. Right? And then the final line to look at would be system, the other print line, P1 equals P2. Should that be true or false? According to the diagram. Should be false. Agree? Right? Because you can see here, you can see P1 pointing to this object here. P2 is pointing to this object here. They're different objects. So that one should be false. It's a reasonably sophisticated example, even though not so many lines, but you ought to know. We're making use of 2 kinds of method, accessor and mutator. Also, inside the method here, we are creating some local reference variable and try to manipulate it. Right? That's why I want to trace the complete program with you. Right? Guys, any questions about this? All right, don't be shy. Right? Okay. Yes. P1 equals, oh, why is false? So P1 equals to P2. We compare the addresses, right? P1, P2, they're not the same addresses. So that's why it's false. Make sense? Okay. Okay. All right. I'll pause a little bit. Yeah, question. Go ahead. Which method? Tell me the name. Move up by. Okay. What about it?
Even though it does return like a value, it still uses the move up.
Yes, that's correct.
Which is it's a mutator method.
Yes, that's fine. Okay, let me clarify a bit. Maybe this is where you got confused with. Let's look at this method here. Okay. First of all, this method here is an accessor, returning a point. Inside the method, we can do whatever that we think we want to do. Okay, let's go over. This line over here creates a local variable, only visible to that particular method called MP. And then we're calling a mutator method over here to modify the contents of MP. And then we return the MP as the return value of that particular method. And we store MP, the return value, into P2, right? That's what we have done. Yeah, that's basically what we're doing. Yeah. Yeah, that's just one example of how you can kind of manipulate the objects and also reassigning the references, but be creative and try. That may be something that will help you a lot for Lab 1 and Lab 2. Yeah? I think for Lab 1 and Lab 2, you will encounter many situations where you just need to figure out what to write inside a method. I think that would be nice for you to struggle a bit on that. Of course, we will be there to help you. All right, so that's the one here. The next one will be a small topic. It's about something called anonymous objects. Well, for those of you who didn't know what anonymous really means, that means something without a name. Okay? So in our context, that means an object without a variable. What does that really mean? Let's take a look. Let's make some analogy. If you look at this particular block over here, so this pair has no reference, but let's understand that. Let's say we got a method which will return the square of the input x. So we can say double square will be x times x and return square. In this case, we are giving the expression over here a name called SQR, right? So SQR over here is the name. On the other hand, alternatively, we can implement just the same method equally well by returning x times x, just this part, without giving it a name. That's also possible, right? That's maybe pretty much what you did, maybe without realizing it. So this is a part that's anonymous. Anonymous expression. And we're going to use the consistent notation here and actually to talk about objects, right? Let's take a look. Let's say this very contrived method. Let's say we want to get a person with this particular name, and it's going to return the person, right? For now, let's say the more verbose version, we say person P is a new person and then with the name, assuming that we got such constructor for now, all right? And then we just return P. So think about this P over here, in some way it's like the name of this particular object. The name, of course, stores the address of the objects. We can make the code simpler if you want to by saying we can just include just this part over here without a name. You can see this part over here is the same as this part over here without storing the object into P. We're doing something very similar. Okay, so this is called anonymous objects. Okay, are we okay so far with a simple case? If you're okay with it, I want to do the exercise together with you. I'm making the following assumption. You have already completed Lab 0 Part 2, but if you haven't, that's okay. But we can still go over. But just remember, any details you might find a little bit lacking for your understanding, it might be because you haven't got there yet for lab 0 part 2. But I want to do this exercise. It shows two things. Okay, so make sure you finish lab 0 part 2, otherwise you will have some difficulty understanding it. Okay, the setup is we got some array attributes, we got integer counter. So these two are the essence for the programming pattern that's covered by lab 0 part 2. Will be required by lab 1 and your programming test, all right? And this is just one method over there just to add a new order, right? For how this works precisely, look at your tutorial or come to me, all right? And this is the part I want to do, all right? The difference is, look at the parameter. If you look at the parameter here, just order objects, just one. If you look at order here, you got 3 parameters, right? You can see you got a string, you got a double, you got a double. Different, the same name, but different parameters. It is something called overloading. That's also mentioned in your review slides. All right. And how do we implement this method here? Okay. Assuming that you already have seen lab 0 part 2, the logic will really be the same to this one here. Okay. So what I will do is I'm going to write it in a way that's the most complete. Might be a little bit verbose, it turns out. Let me write it down. Name, I believe that's product and quantity, will be sufficient for me to create the order. So I would, so this part here, I'm going to say order. Let's say O is assigned to new order. And I'm going to use N, P, and Q. Remember, parameters can also be used as argument. That's what we said before, right? N, P, and Q. P and Q. The first line, we'll create some local objects based on the input parameters. And then we can kind of copy the logic over here. So I can say this dot orders, and then this dot number of orders is assigned to O. And also this dot NOO plus plus. That will be the complete implementation. However, that one could be a little bit verbose. We can improve it. Improvement number 1. This part over here is duplicating what's really implemented in another method. Duplication is always a no-no for your software developments. So this part here is duplication. And the best way to really get around with the duplication is to have some helper method. So what you can do is, in order to implement this, I can treat this method here as a helper method. Okay, I'll write it down. We'll treat this as a helper method. Okay, that's number 1. I can do. Okay, number 1 is going to address this. But I got some trouble here. You can see over here, in order to call this one here as a helper method, I cannot simply just pass N, P, and Q, because that one there is only expecting O, order, right? So what should I do? Well, what I can do here is, number 1, I can simply say this dot add order. And then this O over here can be put over here. This will be improvement number 1. Let me recap very quickly. These 2 lines are duplicating with these 2 lines. We don't want. What we want to do instead is to say, since we got O already over here, we can simply call this method here as a helper method by reusing its lines. So these 2 lines can just be replaced by this single line. That's number 1. Yes?
So this refers to this line?
Hmm?
So like, you say this dot add order, so like, what does it refer to?
Yeah, so I think this dot orders is referring to the array over there. It's referring to this array over here. But to really understand the logic here, I'm not repeating here in the course because that's in your Lab 0 Part 2. Maybe try to finish Lab 0 Part 2 first, and then if you're still having trouble understanding this, you can come to me. It's covered by Lab 0 Part 2. Okay. Unless you got further questions. This add order, okay, add order is actually a name of the method, right? In which case you got either this or this. But now, because you got only a single object here, so it's got to be referring to this version. We're basically calling the add order over here as a helper method. So we don't have to repeat these two lines over here. Okay, good. That's number one. And improvement number two, we can make this part even better. So here, so now you can see we got line number one over here, and also we got line number two, right? We got two lines. Used to be three lines. Used to be 1, 2, and 3. We reduced them into 1 and 2. I can reduce it further into a single line by using anonymous objects. Do you know how? Well, basically, this name over here is not so necessary. What I can do is I can simply move this expression over here and put it in place of O. That's what I can do. All right? So the final solution, the final one, I can reduce these two into a single line. I can say this dot add order, and then I can say new order, and then the NPQ. Yeah, you can see the complete syntax in the slide as well, but this will be the ultimate solution. All right, so guys, two things to pick up from this example. Number one, how you can use another method as a helper method to avoid duplicates. Number two, how you can save some line by using anonymous objects. So these two are both important using this example. All right, so I think I'm pretty much moving to the end. I got two more things to actually talk about for the review. One is about how to use this in a more advanced scenario. I want to use an example to show you, number one. Number two will be about static variables, which I guess you guys may have seen that already in the first year. But I think I'm going to use that for some interesting application. So I'll talk about these two in the beginning of Wednesday. After that, we're going to move on to exceptions. But let me just say one more thing before I let you go. You would be very interested in starting to get prepared for your written test number one. So I would suggest this. You should really start. Let me just go to your lectures page. You should definitely start studying all the slides for the classes and objects, all the 90 slides. You should really study them, number one. And also make sure you complete Lab 0 Part 2 as soon as possible. And while you're studying for Lab 0 Part 2, make sure you also go over this documents over here. That one really explains in detail how you can visualize the programming pattern, right? Since I mentioned day one. Just make sure you get prepared. I think a written test one will be a very good push for you to really review everything you should. And after Wednesday's class, I'm going to release some kind of guidance and some practice questions for you so you can study along the way. Any questions? Everybody is happy? More or less? Good. Thank you so much. I'll see you on Wednesday.